Welcome back to Neural Intel. Today we're diving into something really critical in AI right now, getting powerful AI running smoothly on our phones, on our mobile devices.
Yeah, it's a huge shift, and it brings up a big question.
How do we actually measure how well these large language models, these LLMs, perform when they're running on a phone, not a server?
It's a great question, and honestly, one we haven't had a perfect answer for.
Hmm.
You know, the benchmarks we've relied on, they were built for desktops, for servers, completely different beasts.
Right. Different power, different memory, different everything.
Exactly. Mobile devices have all these constraints: storage space, processing power, battery life is a big one. You need a totally new way to evaluate AI in that context.
Which is why today we're doing a deep dive into mobile MMLU. It's a brand new benchmark. Our goal is really to unpack the technical side, understand why this tool matters for, well, mobile intelligence language understanding.
It's quite significant. Mobile MLU is pretty large scale, over 16,000 questions.
16,000, wow.
Yeah, and they cover 80 different mobile-related fields. The main idea is to test LLMs in realistic mobile situations, the kind of things you'd actually do on your phone.
Okay, so moving beyond those standard, maybe more academic benchmarks.
Precisely, because those just don't capture the real-world limits of mobile.
80 fields.
Yeah.
That's incredibly broad. What kind of mobile scenarios are we talking about here? Give us some examples.
Think about everyday stuff, like getting recipe suggestions while you're out, maybe planning a trip on your phone, managing your to-do list, or even, troubleshooting some weird glitch with an app.
Right, the practical things.
Exactly. It's grounded in how we actually use these devices day to day.
And I heard there isn't just one version, there are two.
Correct. You've got the main mobile MMLU dataset. That's for comprehensive general mobile evaluation.
Yeah.
And then there's Mobile-MMLU-Pro. That one's a subset, but it's designed to be tougher. Similar size to the existing MMLU-Pro, but harder, and it's good for quickly testing the really strong models.
So the Pro version, it's like a stress test for the top-tier models in a mobile setting.
That's a good way to put it. A fast track to see how the most capable models handle mobile-specific hurdles. It lets developers efficiently gauge that upper limit of performance.
Now, performance on mobile,
Mm.
it can't just be about getting the answer right. There's more to it, surely.
Oh, absolutely. That's a key part of mobile MMLU. It looks beyond just, accuracy. What's really interesting technically is that it measures mobile-specific things.
Like what?
Things like inference latency, basically. How fast does it give you an answer?
Mm.
Energy consumption, huge for mobile. Memory usage. These are all critical technical hurdles for on-device AI.
Definitely. A super smart AI that kills your battery in 10 minutes. Not practical.
Not at all. And it even goes a bit further. Mobile MMLU also looks at privacy implications and adaptability.
How so?
It evaluates how well models can process stuff locally, right on the device, which helps keep your data private. And maybe even how they might adapt to your specific way of using the phone over time.
That on-device aspect is huge, especially with recent pushes like Apple Intelligence and similar initiatives. So, what really pushed the researchers to create mobile MMLU? What was the gap they saw?
Well, the core motivation was realizing we just didn't have the right tools. Lots of excitement about on-device AI, right? But the benchmarks for actually testing it properly within those mobile constraints, they were lacking.
The old tools didn't fit the new job.
Exactly. Traditional benchmarks just ignore things like limited memory, battery drain, the need for quick answers, and all the different ways mobile conditions can change.
So, a model could ace a server test but just fall flat on a phone.
It's definitely possible. Now, you mentioned something interesting earlier, order invariance. What's that about in the questions?
Ah, yeah, that's a neat technical detail. The basic idea is that the order the multiple choice answers are presented shouldn't mess with the model's score too much.
Okay, why is that important? Well, sometimes simpler models might have a bias, like maybe they tend to pick longer answers. So the researchers here made sure the wrong answers weren't consistently shorter than the right one.
Clever.
And they double-checked by randomizing the answer order in tests. The results held up. It helps ensure the benchmark tests real understanding, not just picking up on superficial patterns.
Makes sense. And Mobile-MMLU-Pro, you said it was tougher but also more consistent. How did they achieve that?
Right. They used a filtering process for the Pro version. They basically looked at questions where different powerful LLMs gave inconsistent answers where the models disagreed.
Ah, so if the best models couldn't agree, maybe the question was ambiguous.
Exactly. They filtered those out. The goal was to make Mobile MMLU Pro harder for the top models, but also more reliable, better at really telling them apart based on capability.
So it's a finely tuned test for the best mobile LLMs. Okay, let's get into the nuts and bolts. How do they actually build mobile MLAU? What were the steps?
Sure. They laid out four main stages. First up was field selection.
Choosing those 80 fields we mentioned?
Yep. They wanted domains really relevant to mobile use, so they looked everywhere. WikiHow, Stack Exchange, Reddit, forums, even got suggestions from other LLMs.
Trying to capture that real-world usage.
Totally. Focusing on everyday stuff, work tasks on the go, shopping, gaming, travel planning, you name it. Things you actually do with your phone.
That real-world focus seems key. Okay, stage 1, fields. What's next?
Stage 2, generating the questions and the multiple choice options. They used advanced models like GPT-4o and O1 Preview to create scenario-based questions. But crucially, humans were in the loop too, checking for quality and relevance.
Humans checking the AI's work. Good.
And they aimed for 2 difficulty levels. Some questions were straightforward, others needed more complex multi-step reasoning.
Can you give an example of each? Just make it concrete.
Sure. A simpler one might be like, how do I check who viewed my LinkedIn profile? Pretty direct. A complex one might be something like, my scheduled post to Facebook and Instagram via a third-party app failed. Considering API limits, platform policies, and app permissions, what are the likely reasons and troubleshooting steps? See, more layers.
Definitely more involved.
Yeah.
Requires pulling different bits of knowledge together.
Right. And they used a couple of different ways to phrase the prompts when generating these questions, likely to get variety.
These scenario-based questions sound much better for testing real mobile assistants. What about generating the actual answers, the right one and the wrong ones?
This is where they got clever about avoiding bias. After generating the correct answer, they specifically made the incorrect options the same length or even longer.
Longer, why?
It came from their human review findings. They wanted to stop models from just defaulting to the longest answer if they weren't sure. It forces the model to actually understand the content to pick the right one, not just guess based on length. The wrong options were designed to look plausible, too.
That's smart. Addresses a potential shortcut. Okay, field selection, question generation, answer generation. What's the final step in the initial build?
Similarity filtering. Basically, making sure they didn't have lots of duplicate or near-duplicate questions.
How do they do that?
Technically, they used cosine similarity on MPNet embeddings of the questions. It's a way to represent the meaning of each question as a vector, like a point in a high-dimensional space, 768 dimensions in this case, and then mathematically calculate how close those points are. If 2 questions were too similar, they removed 1.
So a technical cleanup to ensure variety. Got it. But it wasn't just automated generation, right? You mentioned human refinement.
Oh yeah, hugely important. It happened in a couple of phases during generation. First, humans checked if the generated questions actually fit the mobile topic and made sense for a real phone scenario.
And if not?
They'd tweak the prompts used to generate them and try again. Second, they validated the incorrect options, made sure they were truly wrong, and again, not shorter than the correct one. This happened for every batch.
So a constant human check for quality and relevance. That iterative process sounds thorough. Was there more refinement after that initial generation?
Yes, specifically regarding the ground truth, the correct answer. They realized some complex questions might actually have more than one valid answer.
Interesting. How do they handle that?
They took 3 top-tier LLMs, GPT-4o, Claude 3.5, and Gemini 2.0, and ran all the questions through them. If all 3 models gave completely different answers, they tossed the question out too ambiguous.
Okay.
For the rest, they use a voting system. If at least 2 out of the 3 models agreed on an answer, that became the official ground truth. This actually resulted in about 5.8% of questions having multiple correct answers listed.
Wow. Using a consensus of top models to define the standard. That seems like a really robust approach. Okay, so after all that work, what does the data actually look like? What did the analysis show about mobile MLU compared to other benchmarks?
Well, the analysis really hammered home that point about the mismatch.
Yeah.
Existing benchmarks like MMLU, they're great for general knowledge, but they cover lots of stuff you probably don't need on your phone. Often advanced calculus, specific legal codes,
Right, not typical mobile use cases.
Exactly. They tend to underrepresent those everyday mobile tasks. We talked about quick lookups, how-to guides.
And evaluating a mobile AI using those benchmarks could be misleading.
Totally. A model might look great on MMLU, but struggle with practical mobile queries. The researchers visualized this using PCA on sentence embeddings, basically mapping the topics.
What did the map show?
It showed mobile MMLU topics clustering in a separate area from MMLU and MMLU-Pro topics, visually distinct. It reinforces that mobile MMLU really is tapping into a different, more mobile-centric knowledge space.
That's pretty clear evidence.
Yeah.
And they developed a specific metric, too, the mobile relevance score.
They did. They actually used GPT-4o as a judge to rate how relevant each question was to typical mobile use. They came up with a formula, the MR score, based on practical value, mobile friendliness, usage patterns.
Okay.
Then they averaged these scores for each topic. And the results were stark. Mobile MMLU questions consistently got much higher mobile relevance scores than questions in MMLU or MMLU-Pro. The distributions barely overlapped.
So not just different topics, but demonstrably more relevant topics for mobile. What about the spread of questions across these topics? Was it balanced?
It seems more balanced in terms of practical relevance. Mobile MMLU has a good mix across things like logical reasoning, survival skills, even basic car care. This contrasts with MMLU-Pro's heavy focus on academic stuff like physics and chemistry, or MMLU's on professional law or ethics.
And the question length?
Also different. Mobile MMLU questions are shorter on average, around 30 words. That fits better with the quick interactions we often have on mobile compared to the longer, more involved questions in the other MMLUs.
Shorter, more relevant, practical questions. That paints a clear picture. Okay, so they built this benchmark. Then they must have tested it out. What models did they use and what did they find?
Absolutely. They ran tests on a good range of current LLMs, from smaller ones around 1 billion parameters up to 9 billion. Models like Gemma 2, Qwen 2.5, Llama 3, Phi 3.5, Mistral. Quite a diverse set.
And they use standard evaluation methods.
Yep, the Elmiel-Avel harness framework, focusing mainly on accuracy to compare performance.
What were the headline results? How did models do on mobile MMLU versus the others?
A few key takeaways. One really interesting one was that the performance gap between the best and worst models was wider on mobile MMLU.
Meaning it's better at telling models apart.
Exactly. It seems to have greater discriminative power in the mobile context. They also saw examples where a model might do well on, say, MMLU, but relatively poorly on mobile MMLU or the other way around.
Which really drives home the need for domain-specific benchmarks.
Yeah.
High score on one doesn't guarantee success everywhere.
Precisely. That tailored evaluation is critical.
What about the overall performance distribution? Any patterns there?
They saw a wider variance, a bigger spread in scores on mobile MMLU, especially for the smaller models. That's useful info if you're trying to pick a model for an actual mobile device where resources are tight.
Right. You need to know how these smaller models really stack up on relevant tasks.
And interestingly, size wasn't everything. They gave an example where Qwen 2.53b Instruct actually outperformed Llama 3.23b Instruct on mobile MMLU, even though they're similar in size.
So architecture and training really matter, not just parameter count. Did they look again at that answer order bias thing during these tests?
They did. They compared their original setup with systematic answer placement and fully randomized placement. The results were very consistent with the randomized version, confirming mobile MMLU is largely order invariant, which is good. But they did note smaller LLMs can still be a bit sensitive to answer order. It just highlights why careful dataset construction matters. They also suggested that maybe moving towards open-ended question answering, like the OpenLM leaderboard does, might be an even more robust way to avoid that issue in the future.
Makes sense, converting it from multiple choice. Okay, last piece of the results puzzle. How did model size correlate with performance across these benchmarks? Did bigger always mean better?
Generally, yes. The trend held larger models tended to perform better across the board. But there were nuances. MMLU scores were often higher in absolute terms, but more tightly clustered.
And the pro versions.
Interestingly, mobile MMLU-Pro scores were generally higher than MMLU-Pro scores for the same models. But again, they stressed that some smaller models, like that Qwen 2.53b, punched above their weight on mobile MMU, suggesting architectural improvements are yielding real gains.
So the experiments really seem to back up the value of mobile MLU for understanding LLM performance in mobile-specific ways.
Definitely. It gives much more relevant insights.
Okay, so let's try and wrap this up. This deep dive really introduced mobile MMLU and its tougher sibling, Mobile MMLU-Pro, as these novel benchmarks specifically designed for the mobile world.
Yeah, they fill a critical gap. We needed better ways to measure models for on-device use.
And what really stands out is that focus on practical, real mobile tasks, plus the careful, technically sound way they built the Pro version using that multi-model consistency check.
Absolutely. And the properties we discussed, the mobile focus, the order invariance, make them solid tools. The data showing that distinct semantic space and the higher mobile relevance scores really confirms they hit the mark.
Right. It's not just different, it's more relevant for mobile.
And the evaluation results give us useful insights showing how performance can vary, why specialized benchmarks matter. It's all crucial for pushing mobile AI forward.
So ultimately, it seems the mobile MMLU family gives us a much stronger foundation, a better way to develop and check language models that are efficient, capable, and actually useful on the phones in our pockets.
Couldn't have said it better.
So to recap for everyone listening, Mobile MMLU offers a technically robust way to evaluate LLMs for mobile. It moves beyond generic tests to focus on performance in realistic scenarios, which is key for the future of on-device AI.
It really treats mobile AI evaluation as the unique challenge it is.
Definitely check out the research paper if you want all the technical details. We've linked it on the Neural Intel webpage.
And it leaves us with a key technical question to ponder. How will specialized tools like mobile MMLU actually drive the technical evolution of AI on our devices? How will they push developers to create models that are not just efficient, but truly context-aware and integrated into our mobile lives in ways we're probably just starting to imagine?